Hello everyone, this is part 2 of homework number 1 for exam 1, and we left off last time with seeing how to solve an equation that is of the form ax equaling b by just simply dividing by the coefficient of the variable. So remember, these are terms you should get used to. Coefficient is the number in front of the variable, the letter. And so to solve an equation that's of that form, ax equaling b, we just divide both sides by a. And we showed some examples of that. So now we'll see how to solve proportions, and it's basically 2 steps. First step, cross multiply, and we saw that last lecture as well. And then the second step, divide. So we will always be given 3 out of 4 of the pieces of information. So proportion, fractions equal to each other. We just simply cross multiply. So in this case, 225 crossed over times x. Now you always want to write the coefficient in front of the variable. So 225x. You don't want to write x 225. And then immediately, as we mentioned before, when you take cross products, after you take the first cross product, write down equals, and then take the second cross product. So 25 times 3, we could just do that on our calculator. 75, no need to show 25 times 3, just do the multiplication on your calculator. And then we divide by the coefficient of x. So we're going to divide both sides by 225. Now, make sure that when you do this division, you only divide by the coefficient of x. You don't write an x down here because you're trying to solve for x. So you're dividing just by the number in front of it so that the coefficients cancel. And we just get 1x over 1 or 1x or just simply x. And then, of course, whatever we do to one side, we do to the other side. So divide both sides by 225. And now we get x is equal to 75 divided by 225. And you want to reduce that. I think the common factor here might be 25. And so we get x is equal to 3 over 9. Oh, that reduces further by 3. And we get 1/3. Okay, so always reduce your answer. And then remember, I also showed you the calculator last time, how we have our special fraction key. This is what makes this calculator very valuable, besides other things. This fraction key is the a with the b over c key. It does a lot of work with fractions for us. And if we want to take 75 over 225 and reduce it, we just type in 75, hit the a with the b over c key. See that little backwards out, which represents a fraction bar. Then enter the denominator, 225, press equals, and it spits out the answer in reduced form. So I would like you to purchase this if you haven't done so already, and you can see it's very advantageous to have. Okay, just one more example. The variable can be in any position, could be in the numerator, denominator of either of these fractions, but the point is we're always given 3 out of 4 pieces of information, and it's a proportion, a fraction equal to a fraction, and we just take the 2-step process, cross multiply, 100 times 7, 700 equals, and then 40 times x, 40x, and now we divide by the coefficient of the variable, and so in this case we're dividing by 40. So the 700 gets divided by 40, and the 40x gets divided by 40. Once again, you never put an x down here, you're only dividing by the number in front of it. I'm one of the only people left that shows these cancellations every time. You don't need to show them. And we get 700 over 40, which reduces to 70 over 4. Let me write it now. X equals, okay, I'm going to say 70 over 4, but then that reduces further by a factor of 2 to 35 over 2. And so that's how we solve proportions. And the final concept is to deal with some application problems. And the key to application problems, I use the term align the units. I mentioned this last time when we set up the proportion, bringing back a page from last class. If you recall the is as is concept, notice how the dogs were in the numerators on both sides and cats were in the denominators. That's the key to setting up the proportion. So when you read a problem and you know it's going to involve a proportion, you can make the primary ratio and then set up the proportion by making sure the units are aligned. So in this example, it says a baseball player has 42 hits in 112 attempts. And it goes further to say if this rate continues, how many attempts will it take for the player to reach 105 hits? So the 42 hits in 112 attempts is the primary ratio. And so I would suggest you include the units in your initial setup. So 42 hits, 112 attempts. We're going to set up a proportion, so it's an equation equating two ratios. And now I know that in this proportion, using the concept of aligning the units, I know that hits have to go in the numerator and attempts in the denominator. So it says how many attempts for 105 hits. So this 105 hits must go in the numerator to align the units. And then you can call this X attempts, you can call it X, N, excuse me, any variable you like. So once the proportion is set up with the units, then you could drop the units. So 42 over 112 equals 105 over X. And then it's just a matter of cross-multiplying and dividing. So cross-multiplying, we have X times 42, which again we write as 42X. Immediately write equals, and 112 times 105. You're going to want to use your calculator for that. So 112 times 105 is 11,760. So 11,760. Now I know many of you at this point are just going to jump right in there and draw a little line and divide by 42. That's fine, but I always take an extra step to show it. And there's a reason why that'll become clear as we progress through more sophisticated equations. But we're just dividing by 42, so X is equal to, alright, that 11,760 is already on my calculator, so I don't need to type it in again. I can just say divided by 42, and that gives 280. So X equals 280. And since it was a word problem, we should probably say what it represents, 280 attempts. So, as I was saying, alternatively, when you're at this point right here, where you have 42x equals 11,760, I always show this extra step for, again, reasons that will become clear later. But it's okay. If you want to do it this way, this is fine. Just watch carefully. It happens in a matter of seconds here. A lot of people won't take the time to rewrite. They're just going to draw a line and put 42, and draw a line and put 42, and then finish it up. Okay? So it's fine if you do that, but I'm always going to show it more literally. Okay, so that's the key to setting up proportion problems. Word problems, applications, your favorite. Got 3 more examples to go through. And again, there's always a primary ratio. So in this example, and you have to be a little bit careful sometimes. You have to wrap your head around the reading in this particular problem. It said a recent study found that 9 out of 15 men in a particular country are clinically overweight. So that means 9 men were overweight out of a total of 15 men. So for every 15 men in the study, 9 of them were overweight. So that's how I'm going to set up my initial proportion. 9 were overweight over 15, I'm going to call it total. Set up the proportion. I know that the overweight goes on top and the total goes on the bottom. And it goes on to say 60 men were overweight. So that goes in the numerator with the overweight. Again, align the units. And we'll call this X. Pardon me. So once you set up the proportion, again, I encourage you to use the units. You can drop the units, so 9 over 15 is 60 over X. Cross multiply. 9x equals 15 times 60 is 900. Use a calculator if you need to. And then divide. And we're dividing both sides by 9 here. And so we get X is 100. And that represents the 100 men in the study. Okay, a couple more. This one is to have some, what we call some conversions at the end that you need to pay attention to. Primary ratio here, though, is this hiker can travel 7 miles in 6 hours. So immediately we could write 7 miles over 6 hours. Set up the proportion equal to, so I know miles goes on top and hours goes on the bottom. And we're asked how many miles. If it continues at that rate, how many miles? So that's the unknown that goes in the numerator. 9 hours goes with the hours on the bottom. And we'll call this X miles. Okay, drop the units. 7 over 6 equals X over 9. Cross multiply. 9 times 7, 63. Equals 6x. Divide. Dividing by 6. And we get, use your calculator, it comes out nicely, 10.5. That represents the hours, and that equals X. But then, pay attention to part B here. Based on the fact that there's 5,280 feet in 1 mile, it wants us to convert this to feet. So, up here, okay, we'll say X equals 10.5 hours. And all that you have to remember about conversions, it's basically just a replacement for us. There's nothing fancy. It's not going to be fancy chemistry conversions where you have a string of terms or anything. It's just going to be a simple replacement. And it's typically multiplication. And that's what we have here. Except I made a mistake. I wrote hours, right? So I wanted to make sure I did that intentionally, just to make sure you were paying attention. That 10.5 and represents miles. Okay, so I intentionally did that because I wanted to bring your attention to the fact that it's very important to set up the units. See, the X was the number of miles. That tells me here, miles. Okay, and as I was getting at, it's just a replacement. There's 5,280 feet is equal to 1 mile. So this mile can be replaced by 5,280 feet. And then it's just a basic multiplication. So obviously use your calculator. 10.5 times 5,280 is, let me double check this, 10.5 times 5,280, 55,440. So 55,440 feet. Okay, and then the final example, just for some reinforcement here. When making breakfast for 40 people, it's recommended we have 6 gallons of milk, and we've got 200 people expected. How many gallons of milk? And then again, a second part, state your answer in gallons and in cups, and it gives us the conversion. You'll never have to memorize any conversions. They will always be given to you. So the primary ratio for every 40 people, we want 6 gallons of milk, and we expect that there's 200 people. So the question, where does the 200 go? See how nicely this works? As long as you know that concept, align the units, and you take the time to write things out, everything works out pretty. So 200 people in the numerator, we'll call this X gallons in the denominator. Drop the units, 40 over 6 equals 200 over X. Cross multiply, we have 40X equals 6 times 200, 1200, and dividing by 40. We get that X is equal to 30. And that represents 30 gallons of milk. Now for the conversion, again, it's just a replacement. I'm going to rewrite 30 gallons, and it's just a substitution, replacement, whatever you want to call it. It tells us that 1 gallon equals 16 cups. So this 1 gallon, then unit of 1 gallon, can be replaced by 16 cups. So it's 30, and in parentheses, 16 cups. And then we typically, it can be multiplication. So 480, use your calculator, cups. Okay, so that's the end of homework number 1. And we can come back and we'll do homework number 2 when you're ready.